Physics reaction video number 68. I think I did a search for AP Physics. I'm not sure. Here we go.
Hi everyone. In this video I'm trying to explain the second part of AP Physics. This is the second video that I'm making for the kinematics, and in this video I will try to explain the concept of the acceleration. What is the meaning of the acceleration, and then I will solve some problems for you. So what is the definition of the acceleration? Acceleration is the change of velocity per unit time. That means if we have change of velocity.
So I just wanted to pause here because this little adjective here is something that I'm, I guess, not consistent with, right? So I think I've probably been heard to say it's the change of velocity per time or change of velocity with time. And so this per unit time is another way of saying in 1 second, right? Like how much in the next second, how much did your velocity change? And of course, the problem with saying it that way is that, during that second, you could be accelerating, right? So you could really, the acceleration could change in the span of 1 second. And so to say, oh, in 1 second this happened, well, there could have been some really, really interesting things throughout that second. And so I'm not sure how much students really think about that word unit when you say that. Is the change of velocity per unit time. It starts to be something that just kind of rolls off them, I would guess. But it's super, super meaningful because that's the same thing as saying per second, right? And I think that it's such a struggle, especially when we start with the scaffold of maybe constant acceleration. So constant acceleration is easy. During that second, the very same things were happening all throughout. But as we start to get into constantly changing things and realizing that you have to zoom in, which is kind of what calculus is all about. I think it gets I don't know, maybe a little bit confusing. Also, you'll notice that unit is being used here in very, very different ways. This literally means 1. This is going to be sort of the dimensions of it, right? The units of it. What is another word? So I think there's a chance for confusion, but interestingly, there's in the equation here, there's no sort of per 1 second. So my guess is this is going to land down here and say per second, and then that's going to be her other way of saying per unit time. So I don't know. I just find that really, really interesting.
Velocity, so we have acceleration. Means if for a motion, velocity always is a constant number, like velocity always is 10 meters per second, and there is no change. So acceleration is 0. So we don't have any acceleration here.
Nice.
But if the velocity is changing,
I love that.
So it means we have acceleration. So what is the acceleration? It is change of velocity, the respect time. That means the time. And when you physics, you see any definition has per unit time, this moves to the denominator. So change of velocity, delta V, per, that means moves to the denominator, unit time, the time you need for that change. So delta V over delta T. So this is the final velocity minus initial.
I guess another interpretation of that unit time is in a unit of time, right? In some amount of time, which helps the students the way she's talking about it here. Just sort of dump it in the denominator and you're good to go. But I think this actually originally comes from the idea that it should be a 1 second or 1 hour. But I guess we use this idea of give me what is your unit of time? I'm kind of stuck on it now. But I really, really liked what she was doing here, right? So taking the words and saying, okay, when you see change of, just write it this way. When you see per, know that there's going to be a denominator. That was really cool.
Final time minus initial. So acceleration is a vector. Why? Because velocity is a vector. So here you have in the numerator a vector, delta V is a vector. So over a scalar, vector divided a scalar number, it's a vector. Because of this, we say acceleration is a vector. And since we are finding delta This is the average velocity. So I have to put the uh, average sign here. So
Mm,
sometimes, most of the time, we
nice.
don't put the sign for vector, and always we write delta v over delta t. So since everyone knows that velocity is a vector and acceleration is a vector. So what is
Cool.
the direction of the acceleration? It is in the direction of change of velocity, not the direction of the velocity.
Hmm.
So if you're doing the one-dimensional problems, it is easy to find the change of delta v. But because it can be in the right or only in the left. So acceleration is only to the right or left. But when we are solving two-dimensional problems, so we have to find delta v, and later I will explain how you can find direction of the acceleration. Okay, so here is important to know that acceleration is a vector, and when we have change of velocity, we have acceleration, and the direction of the acceleration is the direction of delta v.
Cool.
What is the unit
That
of
was
the
really great.
acceleration? So you use the formula always to find the unit for every thing, for every quantity in physics. So A equals velocity. Velocity minus velocity is velocity. What is the unit for velocity? Meter per second. Then the denominator is time, so it is second. So meter per second for over second, meter second squared.
So I've really been struggling with this because of course I jump to this right away and use it and go nuts with it. But honestly, this tells the story of acceleration, right? Meters per second. And actually, I mean, yeah, it takes a little bit more vertical space. You have to write S twice, but come on, a 2 is about the same amount of ink as an S. Um, this is so much more useful to students, I think, than this is. And I really, as a student, I struggled with this. It took me a long time to understand, oh, that's all that means. In fact, I sometimes will purposely mix things like miles per hour per second, right, which drives some people crazy. But it helps say, oh, and the next thing, oh, I just go that much faster. Oh, I didn't realize that's how that works. You know what I mean? So I'm really intrigued by this idea, and I love how she set it up. But it's interesting because she's sort of moved over to here, and this is, of course, the standard way. As you know, my guess is in the homework problems that maybe somebody's going to be given an acceleration, and it'll say, oh, it's 8 meters per second squared, da 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 da. But I do really wonder about the value of just encouraging students to pronounce it this way. It's 8 meters per second, and then like a pause per second. Maybe it's the pause that's problematic. I mean, if you don't put the pause in, 8 meters per second just sounds weird, right? But 8 meters per second, I don't know. I don't know. I think it says a little bit more than certainly than meters per second squared, which is just this really funky thing.
So this is the unit for the acceleration. So acceleration's unit is meter per second squared. Okay, let's solve a simple example. Velocity on object is 10 meters per second at t5. Okay, we have this at time when velocity is 10 meters per second, time is 5. And
I love the fact that the initial time was not zero, right? So if you reflect back on the equation that she had, there was a T1 and a T2. And by not having the beginning be at zero, she's really going to be able to show how the denominator, how the denominator changes. So the denominator is going to be 15, right? And the numerator is going to be 10, right? So it's going to be 10 divided by 15, about 0.67, right? So let's talk about that first of all. So if you're going 10 meters per second, what is that, about 25 miles an hour? This is about 50 miles an hour. And if you go from 25 miles an hour, so like a school speed zone, to almost the highway in 15 seconds. Yeah, this is not super killer acceleration. So the fact that it's less than 1 meters per second, people do this in cars all the time. All right, cool.
and then at time 20, when time is 20, velocity becomes 20 meters per second. So velocity is 20 meters per second. So, and in the same direction. And you know why? Because it is positive. So this is positive.
Mm.
So this is velocity. Okay. So it is,
Oh.
oh, sorry. This is time. So this is velocity.
Nice.
Okay, this is v2.
So I'm always trying to figure out how well teachers can really handle mistakes. And come on, we all make mistakes. It's just dumb to assume that you can get it perfect. So what did she do? She said, "Oh, this is velocity. Why?" Because she knew that 20 was involved in the problem. She's like, "Oh shoot, that's velocity." And at first she's like, "Oh, I typed it wrong." And she's like, "Oh, I'll fix it really quick. I'll just put a V here." Then she's like, "Oh, right?" And I actually thought it was super smooth. I don't think that the students would have struggled with that. I think the students who were sort of on top of it would have said, "What?" And then been, "Oh, great." And the students who might have also been confused would have said, "Oh," but I think that, she didn't draw tons of attention to it. She just fixed it. So I thought that was really great.
Okay, so it is positive. This is positive, and both are in the same direction. So acceleration is delta v over delta t.
Cool.
20 minus 10 over time 20 minus 5, and this will be 10 over 15 meter second squared. So 10 divided by 15, it is 0.666. Well, we can write this, or 0.67 meter second squared.
So those of you crazy significant figure people, this must drive you crazy, right? Because this statement here has an infinite number of significant figures. I love it. I love that. That's so great. All right, so this was great. Such a very straightforward demonstration of acceleration. I really love the definition. I super loved this breakdown here, although I did my little editorial here. I think that a very straightforward problem, but look at the really interesting choices. First of all, the initial time was not 0. There was, something that tripped her up, the fact that 20 showed up in there twice, but very, very different, different meaning. And I think that, understanding that she had done the unit work up here, which led to, okay, therefore we know what the unit is here. It's interesting that these don't say seconds here, but she said it out loud. Again, this incredible value of video. So lots of really cool stuff there. I'm just going to stop there. It seems like a great break point. So hey, everybody, have a great day. And remember, physics teachers are awesome.